Hello, all. A very good morning. Today, we'll be starting the first session of operating system. So, before moving on to see the topics of the operating system, let me first give you all an overview of the syllabus that will be covered in this semester. Coming to the syllabus of this operating system, in Unit 1, we'll give an introduction of the operating system and what are the basic Linux commands we are to be using in this particular thing. In Unit 2, we go for process and CPU scheduling, where we'll see what are different types of scheduling algorithms that are to be used, various system calls for process management, and synchronization. As we move on to the third unit, we'll deal with inter-process communication and the deadlocks that are to be taken care when we have multiple processes. In Unit 4, we'll deal with memory management and virtual memory, the file system interfaces and the various operations we can perform on the files and the necessary system calls required for performing these operations. In Unit 5, we'll go for mass storage structure and what are the various protection mechanisms that are to be dealt with. As we have seen the basic overview of this operating system, now we'll see in detail about the definition of an operating system, what are the operating system objectives, user view of an operating system, and the system view of an operating system. Coming to the first one in basic introduction, as we all know, a computer system is a combination of a hardware where you have external devices or input output devices which are being connected and a software. When I dig out into a software, it can be a system software and an application software. Now, when I say a software, as we all know, a program is a set of instructions, whereas a software is a collection of programs. Now, we'll see what is a system software. As it implies, this particular software will make our system to function properly. And the foremost important system software is nothing but your operating system. And the next one is nothing but the device drivers. We want a particular input or output device to be functioning properly. So just connecting a printer to our thing will not work out. So I want a corresponding software to be installed into it. Similarly, if you want an embedded systems or some other peripherals to be working properly, we go for a firmware and we even have a language translators. As we write the code in a high level language, it has to be converted to a language which is understood by the system, right? So you have a language translators, and to protect our system we even have some utility programs, antivirus, rar files, and all those things. That is all about your application system software. Now we move on to the application software, where in application software, depending upon the purpose or the utilization of the user, we have different types of application software customized to a particular application. If the user wants to operate on the word, you will have different types of word processor. And if he wants to go for creating a tables, we have a database software. And if he wants to work with images, audio, and videos, we even have a multimedia software. And we even have some graphic software as such as Paint. We even have the web browsers. And but make it very clear, this particular application software will not work on its own. You need to have the corresponding system software. Only then this application softwares will work. Now, as you now your people could understand what is a hardware, what is a software, what is an application software, and what is a system software. Now, we'll move on to the basic definition of a operating system. So here, when you see this operating system will act as an interface between the user and the hardware. Now, when you go for this particular hardware, these are the devices, right? So they cannot understand the language which we use. So you want some mediator who will help out so that the user can work with your hardware devices. That mediator is nothing but your operating system. And as a user, you cannot directly interact with the operating system, so you need to have the corresponding application software. So to make you understand this, before we have gone for what is an application software and what is a system software. Now we understood this definition of an operating system. Now this is just an example. You are the user using any of these application softwares. You go for operating them using this operating system. Finally work with your input or output devices. When you want this application software to be installed on your system, it is compulsory that you need to have the operating system to be installed at the starting. And these are some examples of your operating system where you have Windows, iOS. You might have heard these words already, right? Now, Android, Fedora, Linux. So when I go for Android, most of our uh, mobiles are operating on this particular Android operating system. Now, we have seen what is an operating system. Now, what are the basic objectives of an operating system? The first and foremost important objective of this operating system is efficiency. You are using an operating system and you want the users to work efficiently by providing the services from the operating system, and you want all the tasks to be done by the user based on the interface he is using. Similarly, when I go for hardware abstraction, now I'll just give a hardware abstraction. Let me take an example here. We'll just put a paper in the printer and give an option as print. So when I just click on the print, I'm getting a paper as matter printed onto the paper as output. I'm not concerned with what are the internal operations that is taking place. So the operating system will just provide you the hardware abstraction to the user. And when I'm using an operating system as a user, I want it to be used in a convenient way. So I want the interface to be designed in such a way that it is very ease of use. And this operating system, the main important role of the operating system acts as a resource manager. So here you want your system to be acting as a resource manager. So depending upon the requirement of the users or the system, it has to provide the corresponding resources. Now let me tell you what is a resource here. The resource can be a file, it can be a memory, it can be a CPU. You don't think that if I tell it as a resource, it is only the hardware devices. It can be a memory also, it can be a file also. So your operating system will act as a resource manager. So the main objectives of your operating systems are: one is related to your efficiency, how well the operating system is helping you out to execute your programs in an efficient way. How does it provide you an abstraction with the hardware devices, and how ease of interface is provided to you, and how it is acting as a resource manager. So these are the four objectives of your operating system. Now, we have seen what are the objectives of an operating system. Now, when you see this operating system will be viewed in two ways. One is from the user perspective, the other is from your system perspective. So when I go for the user perspective here, we'll see what are all the details a user wants or services he wants from an operating system. And similarly, what are all the services the user wants it from a system perspective. Now, we'll just concentrate on the services or how the user views the operating system. Depending on the type of system the user is using, the viewpoint of the user will be changed. So now user may operate on a personal computer. Now assume user is using a personal computer, a desktop or a laptop. Now what does that he views in terms of an operating system? He just wants an interface to be very neatly organized so that it is very easy for him to use it. And he is least concerned with the performance or the resource utilization. I'm not telling that he'll deny totally, you don't rely upon it, but more importance will be given to the interface. Now, when you go for mainframes, now I assume user is working on a mainframe. So in that case, interface is given a least importance, whereas the resource utilization is given more amount of interface, more amount of importance. Now, if a user is working in a workstation, see, we'll take an example of an organization where each of the user will be provided with a desktop or a laptop, and they are connected to the company's website or a LAN or a WAN or anything. So in that case, from the employee point of view, you only think of the interface, whereas from the employer point of view, he thinks about the utilization of the resources are done in a proper way or not. Handheld devices. Let me take an example here of a mobile. So when you go for that particular handheld device, what is that you expect from the operating system? You want an interface, and mainly you have to deal with the battery lifetime of it. How it is providing you the interfaces or notifications. That thing should be taken care when I go for handheld devices. And we have a particular systems which we call it as embedded systems where the user involvement is very less. So in that cases, you need not concentrate on the interface that is being provided by the operating system. Rather, you concentrate on the services or the functionalities you want it from an operating system. So, depending on the type of the system the user is working, the expectations of his from the operating system will also be varied. Now, we move on to the next one where it is a system view. Now from the point of your system or a hardware, what is that it is expecting from an operating system? It wants the operating system to act as a resource allocator, and it wants the operating system to act as a program controller. Now we have seen in today's class, we have just seen what is an operating system, what are the objectives of an operating system, and what is the user perspective, and what is the system perspective when I am using an operating system. We will cover the next topics in the next class. Thank you.